Let's look at solving multi-step equations and inequalities. Remember that to solve an equation or inequality, we want to get the variable by itself. And to do that, we use inverse or opposite operations. So remember our inverses. Addition and subtraction are inverses of each other, as are multiplication and division inverses of each other. For multi-step equations or inequalities, we have to simplify or use inverse operations to undo more than two numbers. We still use the same strategy, it's just a few extra steps. Now, if you have variables on both sides, we use inverse operations to get them on the same side. Let's look at one. 2x plus 5 equals 4x minus 3. The first thing I'm going to do is box in my variable, but I've got two variables, one on each side. Both have x. Then I'm still going to draw my line down the middle. I want my variable only on one side. So the first thing I'm going to do is I'm going to get rid of that 4x on the right. It's positive on the right, so I'm going to subtract 4x from both sides, and that's going to get rid of it on the right. So 2x minus 4x is a negative 2x. Remember, what we're doing is adding or subtracting the numbers in front of x, our coefficients. I still have a plus 5, and on the other side I still have minus 3. I keep my x boxed in. Now, I'm going to start with what's furthest away, so that's our plus 5. So I'm going to subtract 5, that's our inverse. What I do on one side I have to do on the other. My 5's cancel. Negative 2x comes down. Negative 3 minus 5 is negative 8. So now I have negative 2x equals negative 8. I need to get rid of my negative 2. Negative 2x means negative 2 times x, so I'm going to divide by 2. And what I do on the left, I have to do on the right. My negative 2's cancel, and I get x equals negative 8 divided by negative 2, is 4. So x equals 4 is my answer. Now, sometimes these can get a little bit complicated. Here we've got distributive property, and we've got the variable on both sides. This would take a lot of work to do by hand. That's tough. But we can use Desmos. So let's pause for a minute here, and we're going to bring up Desmos, and I'm going to show you how to do this. When we use Desmos, the first thing we need to do is adjust our settings. So I'm going to click on this little tool at the top on the right. I want to deselect minor grid lines. Make sure my x-axis says negative 10 to 10, and I want the step of 1. And I want to do the same thing for my y-axis, negative 10 to 10, and step 1. I can click the tool again to make that go away. Keep in mind, on our Canvas page, at the top of our modules is a section for Desmos tutorials, and the adjustment of your settings does have an explanation in there as well if you ever forget. On the left side here, in that first bar, we're going to type in our equation just like we see it. So it was 2x plus 1 in parentheses plus 4 equals 4 in open parentheses x minus 2 close parentheses. Notice, I didn't have to solve anything or simplify anything. I just type it in like I see it. What I'm looking for is a line on my screen, and I do see it here. If I didn't, I could click the zoom out button until I did. Here, I'm going to look for my x-intercept. See this little gray point? I'm going to click on that, and it says 7, 0. This x value, x is 7, that's actually our answer. So x equals 7, I can type over here in my second line there, and you notice that draws a blue line right over top of the red line where my original answer was. So that tells me that x equals 7 is the right answer. Now we can go back to our work, and we know that our answer was x equals 7. So that turned the struggle is real into easy peasy. Keep in mind though, we do have some special cases, no solution and infinite solutions. So let's pause here for just a minute, and we're going to take a look at how to tell the difference between no solution and infinite solutions in Desmos. So that's how we do no solution and infinite solution in Desmos. Let's move on to inequalities. What about inequalities? Oh man, we've got variables on both sides. We've got distributive property. We can still do it by hand using our same rules, but it's pretty intense. We can use Desmos. So let's take a look at how to do inequalities in Desmos. I've already got my Desmos set up with my window and my steps. I'm going to go ahead over here to this first line, just like we did with equations, and I'm going to do the same thing. I'm going to go ahead and type in my inequality just like I see it. So I had negative 6x minus 4, and then I have less than or equal to. Now I don't have a key for that on my computer, but I do have a little keyboard here in the bottom. I'm going to click Show Keyboard, and I'm going to find my less than or equal to symbol. And then I can go back up here and finish typing out the rest. 2, in parentheses, x minus 10, close parentheses. Can you click the keyboard again to make it go away? All right, so here I see I've got a line here, and I'm still going to do the same. I'll start out the same way that I did with equations. That line I have at 2, 0 for the x-intercept. So x equals 2 is what that line is. Now, I look to see if it's a dotted line or solid line. This one is solid, so I have the line underneath it. Remember, with our original equation, we had the less than or equal to. So we're going to have that line under it for our answer too. Then I'm going to look at what direction the shading goes. If it were going to the left, then I would have my arrow pointed to the left, but it's not. It's going towards the right, so just almost as if I was drawing an arrow in the direction it was being shaded here. That's the direction my symbol is going to go. So I want greater than or equal to since I have a solid line. I can type this into the second box. X, I need my keyboard for greater than or equal to. I'm going to put in my 2. And you notice I have a blue line and blue shading right over the red, which tells me that that is my answer. And I got it right. So here, we managed to find out that our answer is x is greater than or equal to 2 by using Desmos, which turned this problem from intense into a piece of cake. Now, it is important to know how to do these problems by hand, but it's okay to use Desmos to check our work and to help us out with the tougher ones.